Good afternoon and welcome to the webinar today. My name is Madeline Holzer. I'm the Education Event Specialist here at Zahn, and I'd like to welcome you to our webinar, Breathe Easy, Realize the Benefits of Clean Air. Today we have Mark Castanheiro, the Sales Manager of Quatro Air Technologies. And I just wanted to let you all know, please, if you do have any questions, utilize the Questions tab on your toolbar, and we will address those questions towards the end of our session as time allows. Thank you, Mark, for joining us.
Thanks, Madeline. I appreciate that. Certainly want to make sure that you and your families are all safe and healthy, and wanted to thank you for joining us for this webinar on choosing the right equipment for your lab. Before we jump into the heart of the webinar, probably give you a little background on our company. Quatro Air Technologies is a manufacturer based here in Montreal, Canada, and we've been making clean air equipment for about 30 years or so. We actually started out making only air purifiers, but with the explosion of digital dentistry, we noticed a growing demand for source capture systems as well. And so we responded to the demand for a more complete solution. Today, we sell our dental lab equipment to over 35 countries worldwide. In fact, we're the exclusive OEM of CAD/CAM dust collectors for one of the largest dental equipment manufacturers in the world. As Madeline said, my name is Mark Castanheiro. I'm the sales manager here at Quatro. I only started working for the company about 4 years ago, having spent over 30 years in the needle trade industry. The world of air purification was completely foreign to me. I had to completely change the way that I think, the way that I was brought up to learn the business, anybody's business. The challenge of learning the business from the ground up, as you can imagine, had very steep learning curves. I would often find myself asking the most obvious or simple questions to people that have been in the business for 20 or 30 years. Well, the simple questions weren't just directed at dealers or end users. Most of them were actually directed at people in our own company. I have to tell you that there were many advantages to having my business brain wiped clean. And one of those advantages was being able to see things from a fresh perspective. My simple questions forced everyone around me to relook at how they were doing things, why they were doing things the way they were. Well, ultimately, that led to improvements in the products that we sell, the services that we offer, and even internal processes, all in a very short period of time. So my goal today is to challenge you to look at your labs from that same new perspective that I did when I started in the industry 4 years ago. I really want you to tour your own lab as if you were visiting it for the very first time. Question the way you're doing things. We can all become way too comfortable sometimes when we stop asking questions simply because things were always done a certain way. Well, there's no time like the present to start challenging the way that we're doing things, especially in the dental industry. The fact is that dental materials have become much finer with the popularity of zirconia. Harmful odors are coming from new sources like 3D printers. And viruses and bacteria have become more dangerous, like the ones we've just seen over this last year. So unfortunately, being too comfortable and turning a blind eye just isn't going to be good enough anymore. So I want you to start asking yourself questions. Are we doing the best job to keep ourselves and our staff healthy? Can we be more efficient at reducing contaminants in our lab? Well, you're certainly not alone in that challenge. Fortunately, the skilled people at Zahn are well educated on best practices in the lab. They can help you tweak your current setup and offer valuable advice on new constructions as well. Zahn works really closely with their suppliers and their partners to be up on the newest innovations and concepts. So make sure to hit them up for a consult on how you can improve on what you're already doing. Now, choosing the right equipment for your lab is important for several reasons, the most obvious of which is the health benefits for you and your colleagues. But prolonged exposure to contaminants can also harm your sensitive lab equipment as well. In the end, protecting your equipment and lowering the employee absentee rate in your lab will certainly help to lower your overall operating costs. So these are important decisions that you're making. So today we're going to look at some of the questions that you should be asking to help you make those important decisions. Well, dental labs are very dirty environments. I remember preparing for my very first visit at a local lab here in Montreal, I had this vision of a super clean, sterile environment. Having come from the men's tailored clothing business, I wanted to make a great first impression on the lab owner. So of course, I put on my best navy blue suit for the visit. Let's just say that my navy suits won't be seeing the inside of a dental lab anytime soon. So let's get to a couple of slides here. Let's get to this next one here. There we go. So dental labs are basically small factories. Dust and odors that are generated 8 to 10 hours a day accumulate in the air inside your factory. Now, typical factories, when they're initially built, well, they're designed with a proper ventilation in mind, but not all dental labs are built that way. Most labs are usually grown from within an office-style building envelope, with not much thought to air quality, ventilation, or sufficient air changes. Now, as if the lack of proper ventilation wasn't enough, according to a 2020 study that analyzed the overall unhealthiness of over 900 occupations, 4 of the 5 most unhealthy occupations actually belong to the dental industry. The study analyzed jobs by their impact on workers' health and offered up a score ranging from 0 to 100, with the higher score indicating increased health risk. Now, dental lab technicians landed a very dismal ranking of 4th from the top. So understanding the health risks involved with working in the dental profession has definitely helped me to sell our clean air products. I believe that arming you with important information will help you make the right decisions to create a clean environment for you and your team. And one of the first things that I learned was that the dust that you find on furniture or floors of your lab shouldn't be your major concern. Although prolonged exposure to larger particles can be hazardous to your health, that dust is usually handled by the body's built-in defenses like nose hair or coughing reflexes. If it's big enough to see, then it's big enough for the body to handle in small doses. What you should be concerned with is the dust that you can't see. Ultrafine particles like the dust from zirconia can stay airborne for days at a time. And the smaller the particle, the deeper in the lungs they penetrate. These are the dangerous particles. These are the particles that the body can't expel. I'm not going to start putting up all kinds of gross videos and grim statistics on lung diseases, but let's just say that it ain't pretty. So it is something that you should be conscious of. But dust isn't the only culprit in your lab. Harmful volatile organic compounds, or VOCs, are also a source of concern in dental labs. These VOCs don't just originate from mixing acrylic and burnout ovens, but they also occur when you're trimming or grinding hardened acrylic. And now with the growing popularity of 3D printers and alcohol cleaning stations, there are new sources of off gases and odors present in the lab. So until Quatro can come up with a system that removes dust directly from the lungs, well, we're going to have to focus our efforts on being as efficient as we possibly can at capturing harmful contaminants before they get there. So the way I see it, there are 3 important clean air principles that we should be discussing. One is a source capture system that deals with dust. And whenever we talk about dust collection, we talk about static pressure or suction strength. Generally speaking, dust particles are heavier than gas particles, so strong suction is needed to handle that type of application. Then you have source capture systems that deal with fumes and odors. And when we deal with odors and gases, we should be looking at maximizing airflow, or what's commonly referred to as CFM ratings. The higher the rating, the more airflow you get. And because gases are relatively light, they're more easily caught by a unit with higher CFM ratings. And then finally, we have general air purification for the lab. Air purifiers will capture the dust and odor that source capture systems couldn't. Now, units in this case are chosen based on the size of the room that it occupies and how many air changes they can provide. Now, regardless of the system that you purchase, you should remember the 3 most important words when it comes to air purification. and that's HEPA, HEPA, and HEPA. HEPA filtration is crucial because of their ability to capture microscopic particles with great efficiency. So when it comes to source capture systems for dust, what should you be buying? That's a big question. There are so many products available that it can be quite overwhelming when it comes time to buy. Well, there are compact dust collectors with filter bags for bench applications. And then you have self-cleaning dust collectors for bench applications that don't have filter bags. You have bigger units for CAD/CAM and bench with filter bags. You have compact units for CAD/CAM applications. You have compact units for bench applications with optional odor filters. You have larger units for bench applications with multiple workstations. And you have large units for CAD/CAM applications for single milling machine. And those are just the products that we offer. With all of these choices available, it's hard to know exactly what you should buy. Now, let's come back to this for 1 second. And here we go. So I have very vivid memory of my second day on the job here. I managed to take my first customer service phone call. The customer was looking to buy a foot pedal for a jet stream that was being promoted in the Zahn flyer. Well, I happily gave him the part number, and then I ran into the owner's office to tell him that I had made my first sale and how proud I was. Well, he basically laughed and congratulated me. And then he asked me why they needed the jet stream. What was the application? How many workstations was the unit going to serve? Well, needless to say, my proud moment went out the door as quickly as it came. But I did learn a very valuable lesson, and that is to ask the right questions in order to understand the application better so that we can make the right product recommendation. Now, surprisingly enough, the right questions were the same with just about every phone call that I've taken since. So let's get back to our so it came down to about 3 basic questions. So the first question was, what is the general application? Was it CAD/CAM or was it bench? What kind of workload were we dealing with? Meaning, how many hours a day is a unit expected to be on? Is this a case of bench applications? How many workstations actually need suction? And how much debris are you actually collecting? Is it a handful per day, per week, per year? And finally, there was the question of preference, which came down to asking whether they preferred a system with filter bags or a system that was self-cleaning. And the answers to those questions narrowed down the type of product that we needed for that specific application. So that kind of structure made it much easier for me to narrow down that selection of products that we offered and allowed me to make the best recommendation based on the specifics of each application. So what was the application? Well, if it was a bench application, then we went through simple steps. How many active workstations are we dealing with here? How much dust is being generated? And then, of course, whether you preferred self-cleaning or filter bags. If it was a CAD/CAM application, it was a little simpler. Basically, it came down to how many hours the mill was expected to be working per day. And then, of course, whether you preferred self-cleaning or filter bags. So now that I was asking the right questions, I needed to know why I was asking them. For example, the reason I needed to know how many active workstations were involved was to make sure that I was recommending a dust collector that was powerful enough to handle the possibility of multiple workstations in need of simultaneous suction. I think the traffic analogy explained it best. So if you have 3 workstations that will potentially need suction at the same time, then you'd require a dust collector that's powerful enough to provide adequate suction at each station, each with its own dedicated hose and inlet. Trying to funnel 3 active workstations through 1 single hose and inlet will most certainly reduce your suction and produce very disappointing results, to say the least. So even with a very powerful dust collector, there is only so much air that can flow through a single tube. Here's another example. So say you have a situation where there is only one technician, but there are 3 workstations in the lab. Well, in that case, only one of the workstations would be active at any one given time. And so if you can block off the suction at the inactive stations, then you really only need a suction unit that's powerful enough for one workstation. As a result, a single inlet would do the trick here. Which brings us to the topic of managing airflow for multiple station applications. So blocking off suction at inactive stations will maximize suction by diverting it to where you need it most. And you can do that by installing slide valves or slide gates at each station. Some slide valves that are available on the market are simple gates that just slide open and close. Others can be connected to the dust collector, and they're used to automatically turn the unit on and off when the valve is slid open and closed. These are especially useful. We get a lot of phone calls from labs that are looking to have their dust collectors put in a utility room, in a basement, or in an adjacent room, just to try to cut down on the noise. So these types of valves are definitely useful when the dust collector is far away from the workstations. Now, the reason why we ask how many hours a day the unit is expected to be on has to do with the type of motor that we would recommend. So if you have a heavy duty application where the dust collector is expected to be on for 6 or more hours a day, well, we'd recommend a unit that has a motor that can handle that kind of workload. Basically, it comes down to why sell a Rolls Royce when all you really need is a Jeep. For example, if we take a heavy duty milling application whereby the milling machine is working 8 hours a day, you can make a couple of 5th grade math calculations to help you decide what you should be buying. So if the dust collector is expected to be on, say, 8 hours a day, 5 days a week, 50 weeks out of the year, well, that would total about 2,000 hours a year. So if we take a comparison, let's compare 2 of our own self-cleaning units, the IVAC twins. So our Infinity model actually has 2 brush motors that are rated for 2,000 hours. Our brushless motor unit is rated for about 20,000 hours. So in this case, you can expect to change the Infinity motors every year or so at a cost of about $350. The brushless motor unit, you wouldn't have to worry about motor maintenance for about 10 years or so. And typically, our brushless units cost about $400 more than our Infinity motor models. So you can see how significant the long-term savings are over a 10-year period. So just to understand, oftentimes we recommend a brushless motor. It's not because we're trying to upgrade the purchase, but it really has to do with your needs and what your specific application is calling for. We just don't want you to have to spend more money on changing out motors than you absolutely have to. Still on the topic of managing workload, the reason why we ask about volume of debris that the dust collector is expected to handle has to do with the size of the unit and the volume of debris it was designed to handle. Typically, we would recommend filter bags for systems with lighter volume applications that are usually associated with handpiece work. The heavier duty applications, we would recommend a self-cleaning system. That's usually recommended for grinding, sandblasting applications, or whenever the volume of dust being generated is much higher. Well, the logic is fairly simple. The time and the cost involved in changing filter bags more frequently than you have to should be considered in your overall operating costs. You shouldn't be changing those filter bags more often than you have to. So emptying out a drawer is simpler and faster and is perfect for high volume applications. I'm often asked about the pros and cons, what they are for the self-cleaning versus filter bag systems. So to recap the benefits associated with each system, the self-cleaning systems involve less maintenance. They're recommended for higher volumes of debris and are generally more expensive than filter bag systems due to the electronics involved with the self-cleaning functions. Whereas filter bag systems are generally cleaner, they're less exposure to debris when it's trapped in a filter bag, And they would be recommended for applications where the volume of debris is that's being generated is lighter, and are generally the units themselves are generally less expensive than self-cleaning systems. At the end of the day, it really comes down to a matter of preference. So the choice is yours. So by answering a few simple questions, you can easily zero in on the best solution for any given application. So a little while back, we actually created this selection guide for bench applications that typically summarizes the last 10 or 15 minutes that I've been speaking. The guide offers a very simple way of choosing the right suction unit that's needed based on all of the criteria that we just covered. It covers hours of usage per day, volume of debris being generated, the number of workstations, and even the preferred type of system. So we're distributing this to a few of the Zahn sales reps, and it really helped them to narrow down the products that they should be recommending. I can't imagine how many products are available to the Zahn sales team. And so to help them have a guide to filter through what they should be selling made things a lot easier for them. Now we had the same thing for CAD/CAM applications as well, although this selection guide was a little simpler to read. It's based on workload or usage per day. There's no need to discuss multiple workstations in this case. Once the workload is determined, well, it comes down to a preference of self-cleaning or filter bag units. And again, these selection guides were made very simple, made it very simple for our Zahn partners when they were helping their customers to choose the right Quatro equipment in their labs. So now that you've chosen the right dust collector, well, that doesn't mean that we're done yet. After all, if the tools are not used in the right way, well, you're probably going to be very disappointed with the results. There is one more thing that needs to be considered, and that's accessories. So what is the best capture device or accessory to use at the bench? Well, I can't tell you how many labs have I visited where I saw an open-ended hose just lying flat on a bench that was absolutely covered in dust. Choosing the right benchtop accessory is just as important as the dust collector itself, because accessories are designed with a specific need in mind. An enclosed box, for example, is a perfect application where dust is being sprayed in multiple directions and needs to be contained. If the work you're doing at the bench is pushing debris away from you, well, you would want to consider a rear suction accessory. If the dust is being driven downward, then a downdraft accessory should be something that you need to look at. Or better yet, even a high volume grinding type application calls for more debris storage. So a cyclonic separator sitting under the bench is something that you might want to consider. Cyclone separators collect larger portion of debris that would otherwise overwhelm a dust collector, even the most powerful dust collector. So that will ultimately save you time and money when you consider that filters won't need changing as often. There's quite a variety of accessories available on the market today. This is basically a snapshot of the ones that we offer. Some have pretty neat features that may be beneficial to you when you're looking to be as efficient as possible at source capture. But we touched on the importance of slide valves and their usefulness in multi-station setups. Some of the accessories that are available today actually have those slide valves integrated in the design for added convenience. So all of our accessories have this option, and I'm sure that others on the marketplace are doing the same type of thing. So I think we've managed to cover source capture for dust fairly well. So we should probably move on to odor and fume control. As I mentioned at the top of the presentation, the last few years have introduced new sources that can expose you to harmful odors and off gases. Besides mixing acrylics, you can now add 3D printers and alcohol cleaning stations to the growing list of dental lab applications that produce VOCs. Fortunately for us, the topic of fume extraction is a much more abbreviated one. So that's not to say that it's any less important than dust collection. It's just that the selection process in this case is a little simpler. And it comes down to the space that you have available in your lab. The dental labs, their designs are pretty tight, and they're intended to make use of every square inch of available space. There are fume extraction systems that are designed to work with your individual setup, but they're not always equal in terms of efficiency. For example, the most efficient way to capture odors and gases is to have them contained in a confined space where you can extract the fumes, clean the air, and then send clean air back into the room. Reducing the chances of fumes escaping back into the room from an enclosed cabin is the best way and most efficient way to capture those fumes. The problem I often run into when consulting on a system like our desktop containment system is a lack of space on the benchtop. So a good alternative to that is a containment box. You put something on the floor, maybe a floor unit. Floor units have the versatility to connect hoses and extraction arms to get very close to the source without taking up valuable benchtop space. But even that can present space issues in the lab. Fortunately, there is another solution. A wall-mounted fume hood can be quite useful for burnout applications as well as small 3D printers. And most of these hoods are designed with the option to duct air to the outside. There are some 3D printer manufacturers that actually have built-in exhaust collars on their printers. Not many of them, but there are a few out there. So like in a milling machine application, fumes and off gases are captured at source by connecting a fume extractor directly to the printer's exhaust port. Many 3D printer applications use alcohol cleaning stations. Well, these too give off harmful odors. So depending on the setup, the same fume extractor can be used to serve both purposes. So that pretty much sums up the source capture of dust and odors. Now, source capture is the key to keeping your lab clean and safe. And when it's done properly, source capture systems can rid you of about 70% of contaminants that are generated in the lab. But what happens to the other 30%? Well, that's the stuff that you pick up when you run your finger across the tables and computer screens in your lab. Well, it's also the stuff that can remain airborne for days at a time, as I mentioned, including residual odors. Well, that's where general air purifiers come in. Air purifiers are designed to continuously clean the air. Surprisingly enough, most dental labs that I visited don't have any kind of air purification system installed at all. Although I believe that that is gradually changing, given what we've all experienced in the past year or so. As long as your system is equipped with a medical grade HEPA filter, well, you're not only protecting you and your staff from dust and odor, but also capturing and trapping bacteria and viruses like the coronavirus. When choosing the right air purifier for your lab, there are really no secrets here. Multi-stage filtration is a must, for the simple fact that dental labs generate different contaminants like the ones that we've just covered: dust, odor, viruses, bacteria, and so on. Now, for optimal results, they should be running 24 hours a day, 7 days a week, and strategically positioned in a room to benefit from the recirculating flow of air. Now, our systems, for example, work by pulling air in through the bottom of the unit and pushing clean air up and back out into the middle of the room. Well, the key is to make sure that you have the air purifier, and make sure that you have one that's strong enough to pull air in from the other side of the room and return it just as far. So for dental lab applications, well, it's recommended to have between 8 and 10 air changes per hour. And picking the right unit for your lab can easily be calculated based on that criteria. So let's get back to a little bit of 5th grade math here. In order to calculate the air changes per hour, or ACH, you simply divide the volume of air that the air purifier can move in 60 minutes by the volume of the room itself. So you've all heard the term CFM, or cubic feet per minute. Well, that describes the volume of air being moved per minute by that unit. So if we multiply that CFM by 60, you can get the cubic feet per hour. So let's take our AF1000 as an example. That unit, that air purifier, moves about 500 cubic feet of air per minute. And let's assume that we're talking about a room that is 12 feet by 20 feet with 9-foot ceilings. So the room volume calculation is easy enough to figure out when you multiply the three numbers. In this case, the volume of the room is 2,160 cubic feet. As I mentioned, the AF1000 moves 500 cubic feet per minute, or 30,000 cubic feet per hour. If you divide 30,000 by 2160, you get 13.8 air changes per hour. I know it sounds a little bit more complicated than it actually is, but that's how you would determine the right air purifier for any given space. So focus on the dirtiest room first, and then evaluate the net effect on the rest of your lab. Now, I do realize that there's a lot to absorb here, but I really encourage you all to look at your labs or even the workstation you're currently working at if you're a technician, and try to look at it from a fresh perspective. Don't be shy to ask yourself if this is the best setup to maintain a healthy environment for you and your coworkers. So that's pretty much it for me. I'll open up the floor for any questions or comments you may have. Hopefully I can answer anything that comes up. Madeline, I'll turn it back over to you.
Okay, we do not have any questions come through in the chat. If you can think of anything after our session, please don't hesitate to reach out to a Zahn representative and we'll get you the answers that you need. I'd like to add, I think this is a great idea for labs both large and small, especially given our current climate, to mitigate risk and just for the general health and well-being of lab owners, employees, etc. So I appreciate the presentation today, Mark. Thank you so very much for your expertise and your time. And I hope that everyone has a wonderful Thursday. Thank you for joining us on the webinar.